आज कितना तारीख है? 8 तारीख ना?
हाँ सर।
So that means from the previous class we can say good evening everyone. From the previous class we say कि हम लोग वर्क डन पढ़ रहे थे. फर्स्ट वाला मैंने पढ़ा वर्क डन बाय कांस्टेंट फोर्स, सेकंड वाला पढ़ा वर्क डन बाय वेरिएबल फोर्स, और आज हम लोग जहां से स्टार्ट करेंगे दैट इज फोर्स डिस्प्लेसमेंट ग्राफ. यहां से आज हम लोग अपना पढ़ाई स्टार्ट करेंगे कि फोर्स डिस्प्लेसमेंट ग्राफ है तो हम लोग कैसे वर्क डन निकालेंगे. इसके लिए मैंने पहले ही बोल चुका है कि इफ यू हैव फोर्स एंड डिस्प्लेसमेंट, कभी कभी आर कभी कभी एस से वो रिप्रेजेंट कर सकता है, ऐसे करके कुछ भी एक ग्राफ देगा और तुम्हें यहाँ पे एक पोजीशन दे देगा, सम डिस्टेंस इन मीटर, यहाँ पे सम डिस्टेंस इन मीटर, यहाँ पे दिस आर द सम वैल्यू इन न्यूटन फोर्स, और तुम्हें बोलेगा वर्क डन निकालो. तो एज वी नो वर्क डन इज फोर्स डॉट डिस्प्लेसमेंट एस, इसको कभी कभी एस भी लिखता है. सो when you multiply two physical quantity, two vector quantity, two physical quantity, and we get the third physical quantity, obviously we have to find out the area. So how you get the area? You have to find out work done. That means work done. That means you have to find out area under the graph. Okay everyone, मेरा main target रहेगा जब भी, remember one thing, it's like a brahmastra. Whenever you multiply two physical quantity and you get the third physical quantity and it is given graphically, you have to find out the area from the graph. And when you divide two physical quantity and you get the third physical quantity, always find out the slope. This is the procedure. Now I am giving you a question, then you can understand which type of question examiner can give you from this displacement force graph. Now the question is, network का हालत बहुत खराब है. A question is given like this one ना, कि ये गया, ये आया और फिर ये आया, यहाँ तक है ना. यहाँ पे लिखा है 0, यहाँ पे लिखा है 5, यहाँ पे लिखा है 10, यहाँ पे लिखा है 20, यहाँ पे लिखा है 50 न्यूटन, यहाँ पे लिखा है 100 न्यूटन. This one is the force and this one is the displacement in meter. Question is find the work done. Find the work done by the process. Find the total work done by the process. Everyone, is it okay? Satisfied what I want to say?
Yes.
Everyone, is it okay?
Yes, sir.
हाँ, especially जो new students है, Ankit and one more I think students is there. If you have any doubt, you can tell me. हाँ, तो देखो मुझे क्या करना पड़ेगा, मुझे निकालना पड़ेगा एरिया. इसका किसका एरिया? टोटल वर्क डन, माने यहाँ से लेके यहाँ तक का टोटल. तो मुझे ये एरिया चाहिए. ये क्या है? एक ट्रेपेजियम है, yes or no? So how we get the area of a trapezium? So work done. What is the area of a trapezium? Anyone please tell me? यहाँ पे देखो लिखा हुआ है
base into sum of parallel sides.
Very good. यहाँ पे एक है, यहाँ पे एक है. These are the two parallel side. So half sum of the two parallel side, 50 plus 100, and the separation. What is the separation? 5. इसका हो गया. अब मुझे चाहिए ये मेरा क्या है? एक rectangle है. How we get the area of a rectangle? Perpendicular. ये distance कितना है? 100 into base. 10 and 5. ये 10 और 5 के बीच का डिस्टेंस कितना है? 10 और 5 এর মাঝখানে ডিফারেন্স কত বল? মুক্তা What is the difference between 10 and 5? What is the distance? 5? Yes or no?
Yes, sir.
5. And what about this distance? Ushashri ball এই এরিয়াটা কিভাবে বার করবি? হ্যাঁ? Anyone please tell me? Raj bolo.
Sir, कौन सा एरिया?
Sir, half
Triangle.
into 10 into 100.
Very good. Half into base, that is 20 minus 10, 10 into perpendicular, that is 100. Very good. So what we have, ये हो गया 150 का by 275 into 5, ये हो गया 500, ये हो गया 5 into 100 माने 500. So 75 into 5 कितना हो गया? 150, 150, 300, 375 plus 1000. That is 1375 joule. Yes or no?
Yes, sir.
Everyone satisfied?
Yes, sir. Yes,
Everyone satisfied? Ankit, বুঝতে পারছিস?
Yes, sir.
Pritish. Okay.
Sir.
Now the next question. Next topic. So now we see the work done. So what is work done? Work done is the dot product of force and displacement. We can find out the work done by 3 processes. One is called constant force, one is called the variable force, another one is the graphical method. So by all these 3 methods, we can see the work done. Now the next topic is, sorry, not the question. Now the next topic is very, very important, which is today's main topic, that is energy. Energy. So how you define energy? Energy is defined as capacity or ability of doing work. Capacity or ability of doing work. Capacity or ability of doing work is called energy. Same like work done, it's SI unit, joule, dimension, m L square T minus 2. Yes, scalar quantity. Now यहाँ पे देखो जो most important part is, अरे ये नेट का इतना हालत खराब है ना, क्या बोले, इतना पैसा लेता है लेकिन नेट का हालत बहुत खराब है. देखो energy means so many type of energy present, like heat energy, sound energy, light energy, nuclear energy, magnetic energy, electromagnetic, electrostatic energy. So many types of energy is there. Wind energy, tidal energy, but here we are very concentrate on 2 types of energy, and overall, which is say the mechanical energy, that is the total energy. So here mainly my main concentration is on mechanical energy. Mechanical energy, which is called the total energy also. This mechanical energy is basically 2 types. Means mechanical energy means related to the mechanics. That means rest and motion. ठीक है, रेस्ट एंड मोशन में जो एनर्जी है, ये रेस्ट में उसका पोजीशन कहाँ पे है या उसका शेप स्ट्रक्चर कैसा है, मतलब इंटरनल एनर्जी which is called the elastic potential energy और gravitational potential energy, वो कहाँ पे है with respect to gravity. So this is basically 2 type. One is kinetic energy, when the object is in motion. Another one is potential energy. For a particular instant, this is called the potential energy. Now this potential energy is 2 type. One is the, means in this chapter you have this 2 type. in your syllabus. ऐसा नहीं कि ये दो टाइप का है, इसका बहुत सारा फॉर्म है. इलेक्ट्रिक पोटेंशियल एनर्जीज दे आर, मैग्नेटिक पोटेंशियल एनर्जीज दे आर, न्यूक्लियर पोटेंशियल एनर्जीज दे आर, सब में ही पोटेंशियल एनर्जी है. बट here you have specially two type. One is the gravitational potential energy, another one is the elastic potential energy. And this potential energy is represented by the symbol U, and kinetic energy is represented by the symbol K. Everyone, is it okay up to this?
Yes, sir.
Yes, sir.
Everyone, is it okay? Everyone, is it okay?
Yes, sir.
If you have any problem, you can tell me, because these are very, very important in terms of theoretical point of view also. So we are starting with the first one, very, very important one, kinetic energy, right? Represented by the symbol K or KE. You can write KE also. Now, how you define kinetic energy? The energy possessed by a body by virtue of its motion. The energy possessed by a body by virtue of its motion is called kinetic energy. Now, kinetic energy you can express, for kinetic energy. My first question is express for kinetic energy. Express for kinetic energy. So you can express kinetic energy in two ways. Both are very, very important. Number one, by constant force. Very, very important. Number two, by variable. Okay. Number one, by constant force. Number two, by variable force. Clear, everyone?
Yes, sir.
So examiner can give you anything. If they not answer it, means if they not mention it, sorry, if they not mention it, you can use anyone, which whatever you remember, or you can use Akkar Bakkar, Bombay Bo. But if they mention it by constant force or by variable force, so you have to write that proper one. But for both, first the figure, means the diagram is exactly same. Okay, the diagram is exactly same. You have an object, let the mass is m, you are applying force F, initial velocity is 0, and due to this force applied, let the particle is here. You don't need to write here I, because U itself initial. Okay, initial is U, and the final is V. Okay, final is V. Force is the same apply, and the displacement is S. So due to this displacement, the particle moving from here to here, initial velocity is 0. So I am trying to first solve it by the first one, by constant force. Okay, so my main aim, first one, to show you that one by using the constant force. So see, first of all, we can say we know that V square equals to U square plus 2AS. Is it okay, everyone? Can we know that?
Yes, sir.
V square equals to 0 plus 2AS. That means A equals to V square by 2S. Can we write this? Can we write this?
Yes, sir.
Force equals to mass into acceleration, mv square by 2s. Now work done, W, that is F dot S, and you can see force and displacement, they are in the same direction. So what is the angle? Fs cos 0 degree. If you write it, it will be better, or you can write directly Fs. But if you go through that step, it will be better. So what we can write, mv square by 2s into s, s cancel. So half mv square, and then you have to write a statement. Statement is very, very important. You have to write a statement. This work done appears as a kinetic energy of the body. This work done appears as kinetic energy of the body. Everyone satisfied?
Yes, sir.
Everyone satisfied? Satisfied?
Yes, sir.
Now I'm trying to solve it same thing by variable force. By variable force. So first of all, as it is a force is variable, just always remember one very important thing, that whenever anything is variable, it is written variable, and you have to find out. So that means you have to solve it either by calculus method or by differentiation method. Okay, and variable means mostly by the calculus method. Let's see how you do that. So what we can write, same figure, we know that A equals to dv by dt. Yes or no? ये माने acceleration. Yes or no?
Yes, sir.
And but in this equation, time कहीं पे नहीं है. So I can make it dv by ds into ds by dt, which is called the chain rule. ds by dt is the velocity and dv by ds. So I can write it v dv by ds. Yes or no?
Yes. Yes, sir.
So now my acceleration is v ds by dt. dv by dt t को हटाना था, तो dv by ds into ds by dt. ds देखो कट के dv by dt हो गया, और हमने we know कि velocity is the rate of change of displacement. So ds by dt is v dv by dt. Yeah, dv by ds. So v dv by ds. Now we know force is mass into acceleration, so we can write mv dv by ds. So sorry. Work done dw, that is integration of f ds. Yes, अब बार चलेगा ना, ये जो है ना, इसका क्या हुआ है, नेटवर्क का बहुत हालत खराब है, या ये मेरा ही लैपटॉप पे हो रहा है, आई डोंट नो. नेटवर्क कैसा दिखा रहा है? वीक दिखा रहा है बहुत.
नहीं सर, आपका तो ठीक चल रहा है.
फिर ऐसा क्यों हो रहा है? बीच बीच में उड़ जाता है. वी नो दैट वर्क डन इज एफ डी एस, व्हाट विच वी कैन राइट mv dv by ds into ds, and see, my initial velocity is 0, final velocity is v. If I take work done 0 to w, right? So my work done, that is ds, I can cancel m v dv u to v. You understand that part? Force
Yes.
into displacement, the force is this much, so I can put it here. Force is mv dv by ds, and ds is ds cancel, this one and this one cancel. So mv dv m v dv, which we can write m v square by 2. u is 0, right? u क्यों लिखा जब 0 लिखा ही है पहले already. So I can write it u to v, when 0 to v. So m v square minus 0 by 2, that is half m square. So what we can write, this work done appears as kinetic energy of the body. Yes or no?
Yes, sir.
Okay. So I think you understand. One is the constant force. One is one by the constant. Second one by the variable force. Now the same thing. I'm doing the same thing. Only the difference is that for the next theorem, here we take initial velocity 0, final velocity v. Next time I'm doing the same thing, repeat it, but I'm not taking initial velocity 0. Let u is the initial velocity and v is the final velocity, and I just show you the change in kinetic energy. That is called work energy theorem. So don't confuse, huh? ये वाला जो है कि by using constant force and variable force, you are finding the value of kinetic energy, and the next one is work energy theorem. I'm again repeating, you don't confuse. If they say you work energy theorem, you have to write the next one, which I'm now show you. Everything is same, खाली u 0 नहीं करना है. So my next heading is work energy theorem. In this work energy theorem, everything is same. First, you have to draw this block. Initial forces apply. Initial velocity is u. Final velocity is v. Displacement is s. Forces apply on the direction of displacement. I am trying to solve it by two process. Work energy theorem by two process. The first one is for constant force. For constant force, and similarly I can try the second one for variable force. So first I'm trying to solve it by constant force. Obviously they don't give you both at a time. Either they give you for the constant force or they give you for the variable force. If they not mention it, you can use any one, but if they mention it, most probably they mention it, okay, constant force or variable force. If they say you constant force, that means your force is constant, so we can say we know that v square equals to u square plus 2as. So a equals to v square minus u square by 2s. Force equals to mass into acceleration, m v square minus u square by 2s. So therefore work done f dot s, that is fs cos 0 degree, which is fs. That means m v square minus u square by 2s into s, that is half m v square minus half mu square, that is kinetic energy final, kinetic energy initial, that is change in kinetic energy, and then now you have to write this provide the work energy theorem for a constant force. This process, sorry, this proves the work energy theorem for a constant force, for a constant force. Okay, everyone. Now I'm trying to solve it same thing by the variable force. So same way I can write, same way the last one, exactly same. देखो कुछ फर्क नहीं है, सिर्फ वहाँ पे u 0 था, यहाँ पे u 0 नहीं है. यहाँ पे हमने जो लोअर लिमिट है, instead of 0 we have to write u. So what we write, we know a equals to dv by dt, that is dv by ds into ds by dt, that is v dv by dt. Sorry, dv by ds. Now we know force equals to mass into acceleration, that is mv dv by dt. So work done dw, that is एक काम कर सकते हो, वर्क डन डायरेक्ट लिख सकते हो, वर्क डन w, that is integration of f dot ds या f ds, that is f ds cos 0 degree, that is basically f ds, you can write directly also. So mv dv by ds into ds, initial velocity u, final velocity v, ds cancel, so I can take m outside, v dv, u to v. Only the difference is last time we use u is 0, that time u is not 0. So what you have, that is equals to m v square by 2 u to v, that is m v square minus u square by 2, that is half mv square minus half mu square, kinetic energy final, kinetic energy initial, change in kinetic energy. Now can write the same language. This proves the work energy theorem for variable force. Okay, this proof.
Sir,
Ah,
sir, can you explain the proof once again? Sir, actually I got disconnected.
yes, work energy theorem for a variable force. See, for this one, just 1 minute. For this one, first I am doing a equals to dv by dt, when velocity, acceleration is rate of change of velocity, and we make it in the different form, that is called the chain rule, dv by ds into ds by dt. And what do you mean by ds by dt? Rate of change of velocity, displacement with respect to time is velocity. So I can write v dv by ds, that is my acceleration. We all know force is mass into acceleration. So force equals to mass into v dv by ds. I write this. Now, so for work done is w, that is integration of f ds. Force and displacement are in the same direction. So you can write f ds cos 0 is 1. So we can write f ds direct also. Last time I'm writing it directly, but that is the proper way you can write it, f ds. Now, what is the value of f? This is the value of f, mv dv by ds, and ds, this cancel out. So what you have, mv dv, m is the constant, mass is constant always. In the mechanics, mostly the mass is constant, so we make it outside. So we have v dv, initial velocity u, final velocity v, and this is the integration of v. So now, what is the integration of v dv? V square by 2. Initial is u, final is v, so upper minus lower by 2. So v square minus u square by 2. Half mv square minus half mu square. That is kinetic energy final minus kinetic energy initial. That is change in kinetic energy. And this proves the work energy theorem for the variable force. Last one is the constant force. Now is the variable force. Everyone, is it okay?
Yes, sir.
Okay.
Yes, sir.
So first we try to show you the proofs. Then once you understand all the proofs, then it will be better for you to show the I can show you the numerical part, conservation of energy and all. But before that, I must show you these proofs, because these are very, very important in terms of your board exam, in school exam. Next heading is potential energy. Potential energy. So how you define potential energy? देखो, you can define potential energy in two way. Very very important, very confusing. Very confusing, very important. See, देखोगे तुम लोग का जो इंडियन राइटर का बुक है उसमें एक लैंग्वेज होता है, फिर इफ यू सी द फॉरेन राइटर बुक उसमें एक लैंग्वेज होता है, तो समटाइम एवरीवन कंफ्यूज करे तो करे क्या, सो डोंट कंफ्यूज। हाँ, पोटेंशियल एनर्जी को देखो हम लोग क्या क्या बोल सकते हैं। फर्स्ट ऑफ ऑल, पोटेंशियल एनर्जी इज द internal energy. Internal energy. Potential energy is the internal energy which always oppose external work done. Which always oppose external work done and support internal work done. That means if you want to express potential energy in terms of external work done, potential energy is negative of external work done because it opposing. And if you want to express it in terms of internal work done, it will support, mane positive. So Indian writer mein mostly they use this one, and mostly foreign writer H.C. Verma they use this one. So अपना choice है। इंडियन राइटर का ये चॉइस लेने का एक और कारण है कि हम लोग छोटा से पढ़ते आए हैं। डेफिनेशन ऑफ इलेक्ट्रिक पोटेंशियल इज वर्क डन पर यूनिट चार्ज पार्टिकल। तो वहां पे क्या होता है कि वर्क डन पर यूनिट चार्ज पार्टिकल 12th में आके या 12th में आके जब इलेक्ट्रिक पोटेंशियल पढ़ोगे, वर्क डन इज नेगेटिव ऑफ पोटेंशियल एनर्जी इज द नेगेटिव ऑफ वर्क डन बाय चार्ज पार्टिकल, सब कंफ्यूज हो जाएगा। सो दैट वर्क डन इज द इंटरनल वर्क डन, माने अगर चार्ज पार्टिकल खुद ब खुद आए, दैट वर्क डन। आर यू गेटिंग माय पॉइंट?
हाँ सर।
नहीं समझ में आया? किसी को मुर्गा बनाते हैं, किसको 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 किसको? सोमदीप, प्लीज टर्न ऑन योर वीडियो। सोमदीप,
यस सर।
प्लीज टर्न ऑन योर वीडियो।
सर পারবো না।
কেন, তুমি কি জামা কাপড় পরে নেই নাকি?
না স্যার, তা পরে আছি।
তাহলে কি
ক্রিম
হয়েছে?
মাখানো পুরো মুখে।
ক্রিম?
পিম্পলের জন্য স্যার, ডাক্তার রেকমেন্ড করছে।
উষশ্রী ভিডিওটা অন করতো। ভেরি গুড। আচ্ছা, এবার 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 কান ধর। ইয়েস, দ্যাট ইজ দ্য, আরে ধরছিস কেন? ধরার পেছনে ধরিস না। আনমিউট কর। So you can express the potential energy in two ways. Number one, potential energy is the internal energy which always opposing the external work done or supporting the internal work done. So now it's your choice in which way you want to express it. Tar mane U is negative of external work done, that is also right, or positive of internal work done, mane work done by the system, and it is work done on the system, work done. Both are right. Okay, both are right. Now first I am trying to show you gravitational potential energy. Gravitational potential energy. Potential energy. Now first I am trying to show you gravitational potential energy. Now what is gravitational potential energy? देखो, इन प्रैक्टिकल जो ग्रेविटेशनल पोटेंशियल एनर्जी है वो हम लोग अभी नहीं एक्सप्लेन करेगा, बिकॉज you are not understand now, because now we don't know gravitation. You have one chapter which is I think after rotation, वो chapter है gravitation. So when we show you that gravitation, then we express again that potential energy, and वही potential energy का, gravitational potential energy का वही perfect definition है। ये जो gravitational potential है ये एक particular case है, and what is the case? The case is कि h must be very less than radius of the earth। माने हमारा जो वर्क डन होगा, हम लोग जो वर्क डन देखेंगे इसमें जो ग्रेविटेशनल एनर्जी होगा your height is 10 meter, 20 meter, 100 meter, 1 kilometer with respect to radius of earth, which is 6400 kilometer. That radius is that height is very less. तुम्हें इस वर्क पावर एनर्जी में तुम्हें सैटेलाइट एक को अर्थ से बहुत दूर ले गया क्या होगा नहीं पूछेगा, वो ग्रेविटेशन चैप्टर में पूछेगा। यहाँ पे जो भी हम लोग पढ़ेंगे that is h is very less than r, माने nearly on the surface of earth। ये अगर नहीं होगा तो क्या है, हम लोग ग्रेविटेशन में जब पढ़ेंगे तब इसको समझ में आ जाएगा कि मैंने ये क्यों लिखा था, मैं वो वहां पे दिखा दूंगा, लेकिन यहाँ पे जरूरत नहीं है। यहाँ पे सिर्फ हमें इतना जानना है that I think all of you know that also कि gravitational potential energy is mgh. Now I just want to show you how the gravitational potential energy is mgh. Suppose m is the mass of the block and gravitation acting downward. Because of that, you move the particle from this position to this position, means you move it to a height h. Yes or no, everyone?
Yes, sir.
So when you move it from ground to a height, so actually you are doing work against gravity. Yes or no? You are doing work against gravity or not? Tell me.
Yes, sir.
So your work done. So work done. That is mg is the force acting downward, and you are move it opposite direction h. And what is the angle between them? 180 degree. So what is my work done? Minus mgh. Yes or no? Yes or no? This
Yes,
work
sir.
done is positive or negative? Negative.
Yes, sir.
And this is my external work done. So how you define gravitational potential energy? Gravitational potential energy, that is minus of external work done. So minus of minus mgh, that is plus mgh. So from that I can realize one thing: if my height is upward, mean positive from the reference, my gravitational potential energy is positive. Mean if we release from a height h, that means positive height, so my gravitational potential energy is positive. If I release it from the negative height, mean down, so my gravitational potential energy is negative. And if it is zero, so then it will be zero also. So I can write in that way. अगर हम इसको इधर mg हम इधर ले जाते हैं, then also my angle is 90 degrees, so work done is zero, potential energy is zero. So what I can say here, I can say here कि gravitational potential energy can be positive, negative, or zero. Satisfied, everyone?
Yes, sir.
Yes, sir.
अच्छा, इस ग्रेविटेशनल पोटेंशियल एनर्जी के साथ साथ तुम लोग अगर देखोगे दो छोटा छोटा कॉन्सेप्ट आता है, कभी कभी भाइवा वगैरह में, स्कूल का फाइनल, स्कूल एग्जाम में भी पूछ देता है। कभी कभी ये जानना भी जरूरी है, बहुत जगह इंटरव्यू वगैरह में भी पूछ देता है। ठीक है, तो कंजर्वेटिव TIV, conservative and non-conservative force. Conservative force and non-conservative force. This is the question. Okay, define conservative force and define non-conservative force. I am trying to define one by one. First, conservative. How you define conservative force? How you define conservative force? देखो, मानो this is my initial position and this is my final position. Initial position and final position. If I'm doing work from initial position to final position by this path, by this path, and by this path, so my force is conservative. conservative force. Huh? My force is conservative in that time when my work done does not depend on the path. Mane, let it be the first one, let it be the second one, let it be the third one. In all these three, work done by first one, work done by second one, and work done by third one are equal. Mane, if work done is path independent, then the force is conservative. Example, gravitational force. यार क्या होता है, खुद ब खुद क्यों उड़ जाता है ये? Gravitational force, electrostatic, magnetic, etc. These are the example of conservative force, where the work done is path independent. It does not depend on the path, it only depends on the initial and final position. It only depends on the initial and final position. ठीक है everyone?
हाँ सर.
Now the second one, which is called non-conservative. Non-conservative. What do you mean by non-conservative force? ठीक इसका उल्टा, if work done depends on path, then the force is called non-conservative. Example, frictional force. ठीक है? Okay, everyone?
Yes sir.
Viscous force. These are the example of non-conservative force. कारण विस्कस फोर्स जो है वो भी फ्लूइड फ्रिक्शन होता है, फ्रिक्शनल फोर्स ही हुआ, वो भी एक तरफ का. इसके बाद इसके बाद एक क्या कहते हैं उसको, एक प्रूफ है, फिर हम लोग न्यूमेरिकल में जाएंगे. ये जो है प्रूफ है कंजर्वेशन ऑफ एनर्जी का ही. अच्छा, कंजर्वेशन ऑफ एनर्जी क्या है ये भी बता देते हैं थोड़ा. कंजर्वेशन ऑफ एनर्जी, कंजर्वेशन ऑफ एनर्जी का मतलब क्या है? कंजर्वेशन ऑफ एनर्जी का मतलब है मेरा टोटल एनर्जी ऑफ अ सिस्टम रिमेन ऑलवेज कांस्टेंट. तो यहाँ पे जो टोटल एनर्जी है, दैट इज द मैकेनिकल एनर्जी, ये सिर्फ दो ही तरह का होता है. वन इज काइनेटिक एनर्जी, अनदर वन इज पोटेंशियल एनर्जी. कभी इसको पोटेंशियल एनर्जी बोल सकते हो, माने पोटेंशियल एनर्जी इज ग्रेविटेशनल पोटेंशियल एनर्जी, कभी स्प्रिंग पोटेंशियल एनर्जी, बट द पोटेंशियल एनर्जी दैट इज इक्वल्स टू कांस्टेंट, माने नो लॉस, सेम रहेगा. दैट इज कॉल्ड द कंजर्वेशन ऑफ एनर्जी. यस एवरीवन? माने एक जगह का एनर्जी दूसरा जगह में कन्वर्ट होगा. ये सब नो?
Yes sir.
अच्छा, सो कंजर्वेशन ऑफ एनर्जी. अब यहाँ पे हम लोग पहले एक क्वेश्चन लेंगे, दैट इज द कंजर्वेशन ऑफ एनर्जी. अच्छा, इसको मैं बाद में कराऊंगा. मेरे को ना बैठे बैठे ना तबीयत कैसा लग रहा है, थोड़ा उठना पड़ेगा. तुम लोग एक क्वेश्चन कम से कम दे देते हैं पहले. क्वेश्चन इज, यू कैन ट्राई दिस फ्रॉम दिस वन आल्सो. क्वेश्चन इज, हाँ, एक एक ट्रैक है, एक ये मेरा सरफेस है, ग्राउंड, और यहाँ पे मेरा एक ट्रैक है लाइक दिस। यहाँ पे एक ब्लॉक है जिसका मास m है, इसका हाइट है 10 मीटर और इसका हाइट है 5 मीटर। ठीक है, ट्रैक जो है इनिशियल वेलोसिटी रेस्ट इज एट रेस्ट, तब ये जो है u जो है यहाँ पे 0 है, टाइम जब 0 है। ट्रैक इज स्मूथ, track is smooth. What do you mean by the track is smooth? No friction is there. That means it is independent of path. So ये जब यहाँ पे आया, यहाँ से ये v velocity से इस path को रिलीज करेगा, और ये क्योंकि ये h height पे है, so ये यहाँ पे प्रोजेक्टाइल होके यहाँ पे गिरेगा। तो ये पॉइंट, सपोज दिस पॉइंट इज a, इस पॉइंट से ये पार्टिकल जहाँ पे गिरेगा उसका रेंज क्या है? फाइंड द रेंज। I'm not giving you a very tough question, so try and tell me. I'm just so क्या आंसर आया इसका? देखो, very simple. We can use the conservation of energy. ये मेरा एक पोजीशन है, पोटेंशियल एनर्जी यहाँ पे. So let this point is A point, let this point is B point. From this one I can say total energy at A is equals to total energy at B. At A पे initial velocity 0 है, तो potential energy is mg h1. I can write directly that mg h is 10 plus u0, that means kinetic energy is 0. That is equals to mg, here the height is 5 plus half m v square. So from that I can get this value. So mg 10 minus 5 half m v square, I can cancel this mm. So mass दिया हुआ रहे ना रहे कोई फर्क नहीं पड़ता. Yes or no? So 10 into 5 into 2, that is v square. So v square is root under 100, that is 10 meter per second. Once you get this, now I think you all remember the range of projectile type 2. Horizontal range is velocity along x-axis into time of flight, that is u into root under 2h by g. u कितना निकाला है? u is 10. height कितना है? 2 into 5 by gravitation 10. तो 10 by 10 cancel out, so that is 10 meter. Yes or no? Everyone, is it okay?
Yes, sir.
So the next is next very important theorem. आज theorem ही ज़्यादा करेंगे. Question is conservation of mechanical energy which is the total energy, ठीक है, in a freely falling body. ये तुम लोग क्लास 10 में किया है, आई थिंक सो. तो इसके लिए क्या है, हम लोगों ने एक ब्लॉक ले लिया.
हाँ सर, वो तीनों टाइम पे इक्वल्स टू mg h ही है.
बड़ा इजी था क्लास 10 ना.
हाँ सर, 11 तो पूरा ही मिलता है.
हाँ
सर 11 तो पूरा ही उल्टा है।
this is the initial position. Free falling माने your initial velocity is 0. 12 relatively easy है. This point is B.
12 में फिर 11 का रहेगा ना सर?
नहीं, लेकिन 12 ज्यादा इजी है. A point है, B point है, C है. This is before hitting the ground. This is in between. Let that distance is x and let that distance is h minus x. So हमें दिखाना है at A, at B and at C my total energies remain constant. That is the total mechanical energy remain constant. So at A, U is 0, so my kinetic energy is 0. Potential energy is mgh, so my mechanical total energy or mechanical energy that is potential energy plus kinetic energy, that is mgh plus 0, that is mgh, equation number 1. Now at B, what is my speed? V square equals to u square plus 2as. Initial velocity 0, let it be the vb, velocity at B, 2g and the x. So we can write velocity at B is root under 2gx. So what is my kinetic energy at B? Half m vb square. So half m root under 2gx whole square. So half m into 2gx, that is mgx. Yes or no?
Yes sir.
This is the kinetic energy. Now, what is the potential energy? mg, the height is h minus x. So what is my total energy? Total energy is potential energy plus kinetic energy. Potential energy is mg h minus x, kinetic energy is mgx equals to mgh. So I again show you my total energy is same. Now at C, before hitting the ground, so v square equals to u square plus 2as. Initial velocity 0, v square at C 2gh. That means velocity at C is root under 2gh. So my kinetic energy half m vc square, that is half m into root under 2gh whole square, that is mgh. And potential energy, as my height is 0, so 0. So what we can say, my total energy, that is potential energy plus kinetic energy, that is 0 plus mgh equals to mgh. So at A, B, C, my total energy remain constant. So from A, comma B, comma C, total mechanical energy remain constant or conserve. Yes. इसके साथ साथ तुम अगर एक ग्राफ दिखा दो तो क्या कहना, माशा अल्लाह जिसको कहता है. ये है मेरा एनर्जी स्ट्रेट लाइन. देखो काम ही नहीं करता है कभी कभी. क्या हो जाता है इसका, भगवान जाने. ये है मेरा एनर्जी, ये है मेरा हाइट। ये है मेरा हाइट। माय टोटल एनर्जी रिमेन फिक्स। ये मानो हाइट h है। माय टोटल एनर्जी इज mgh and this is my one straight line. This is my another one straight line. So देखो, when my height is 0, my energy is 0. When my height is maximum, my energy is maximum. That means this is my potential. और ठीक इसका उल्टा, when my height is 0, before hitting the ground, my velocity is maximum, and at the maximum height, my velocity is 0. So this is my kinetic energy. Okay, so मानो total energy 10 joule है, अगर potential energy 2 joule है, kinetic energy potential energy 8 joule है, kinetic energy 2 joule, potential energy 6 है, 4 5 5, ये है potential energy 2, kinetic energy या 4 6 2 8 0 10. Clear? Everyone, is it okay?
Yes, sir.
तो देखो, अब न्यूमेरिकल है और नेक्स्ट स्प्रिंग है। स्प्रिंग में आज नहीं कराऊंगा, दैट आई शो यू इन द नेक्स्ट क्लास। एक न्यूमेरिकल और करा देता है फ्रॉम दिस कंजर्वेशन ऑफ एनर्जी। क्वेश्चन नंबर 19। हाँ, तुम लोगों को मैं ये शीट भी भेज दूंगा। क्वेश्चन नंबर 19 वर्क का शीट नहीं भेजा है ना। क्वेश्चन नंबर 19 में ऐसा है कि ये एक सरफेस है और ऐसे एक आया यहाँ तक, और फिर ये ऐसे करके शायद रफ सरफेस है। लेट्स सी, दिस इज 1 मीटर और यहाँ पे एक ब्लॉक है, मास इज m, दिस पॉइंट इज a, this point is b. Now I read the question. A block of weight 10 Newton. Weight 10 Newton money mg is 10 Newton. A block of weight 10 Newton travel down a smooth smooth curved track AB jointed to a rough horizontal surface. The coefficient of rough horizontal surface, the coefficient of friction is 0.2. ये rough surface का coefficient of friction 0.2 है. With the block, if the block starts slipping on the track from a point 1 meter above the horizontal surface, how far will it move on the rough surface? माने मुझे मेनली दो चीज चाहिए। यहाँ पे जब आएगा इसका वेलोसिटी क्या है और ये कितना देर में जाके रुकेगा, मतलब दैट इज द व्हाट इज द डिस्टेंस ऑफ दैट। एवरीवन, इज इट ओके?
Yes, sir.
तो सबसे पहले मुझे कंजर्वेशन ऑफ एनर्जी करके यहाँ का स्पीड चाहिए। तो ऑब्वियसली आई कैन से हियर एज इट जस्ट रिलीज इट, सो पोटेंशियल इन काइनेटिक एनर्जी इज 0। कुछ कभी कभी अगर स्पीड दे दे सो यू कैन टेक दैट एज ए काइनेटिक एनर्जी। यहाँ पे नहीं है, तो टोटल एनर्जी एट ए इक्वल्स टू टोटल एनर्जी एट बी, टोटल एनर्जी एट एम जी एच, एच इज 1 and here half m v square. So I can cancel this. So v is root under 20 meter per second. यहाँ का जो स्पीड है वो root under 20 meter per second है। अब यहाँ पे देखो, we already mentioned you force, that is mass into acceleration, that is mu mg. I think all of you remember. Tendency of motion, this one frictional force opposite direction में जाएगा। So ये acceleration नहीं है, ये retardation है। Retardation is mu g, 0.2 into 10. That is, we can take say 2 meter per second is the retardation. So if my speed is root under 20, कितना distance में जाके ये रुकेगा? V square equals to u square plus 2as. my final velocity is 0, initial is root 20 ka square minus, because of the retardation, 2 into 2 into s. That means 4s is 20, s is 20 by 4, that is 5 meter. Yes or no?
Yes, sir.
So in this way you can solve questions. Okay, so I am stopping the recording here for today.